So I'm here to talk about Puppet at Bazaarvoice, as the title explains. It's a little bit more qualified than that. It's really Puppet as Dave, myself, has worked at Bazaarvoice. So first and foremost, a little bit about myself. My name is Dave. I guess one of 3, 4 that are here. I'm a DevOps engineer at Bazaarvoice. Started working with Puppet in 2008 while working at BioWare, and gamers out there. BioWare, makers of Mass Effect, Star Wars, The Old Republic, which was my last project there.
Neverwinter Nights.
Neverwinter Nights. Yes, everybody's got a favorite. It was at BioWare that I really kind of got my feet wet with Puppet. Before that, I had actually messed around with some CF Engine. But at BioWare, I started off with version, I think about 2.5, something like that. Or 2.4, as my slide says. There, we created a very large network of Puppet nodes, about 14,000 globally. We had about 5 different data centers spread across California, Virginia, Ireland, Australia, Texas. And we all had all those nodes reporting back to a centralized Puppet dashboard. Pretty awesome, the amount of information we got out of that. I'm not going to lie to you, that dashboard did not stay up 100% of the time. So anyways, my contact info, you can reach me on LinkedIn. Feel free to drop me a line. And where do I work now? Bazaarvoice. Bazaarvoice is awesome. What do we do? Well, one of the things that we do, aside from our product offering for our customers, but I don't really care about that. I'm a DevOps engineer. We do embedded DevOps. It's really awesome. What is that about? Well, it's about having individual product teams that are responsible for the operational success of their applications. So therefore, no centralized operations. What's a really great thing about that? Well, being in DevOps embed, you have to teach the other developers how to do operations. So if you want to work at a place where you get to tell other developers that they are on call and they need to be ready to support production, send me your resume. It's an awesome place to be. We also work on really great stuff. Our 2.0 stack is 100% using Amazon Web Services, so we're very, very agile. And we also work on really cool projects like Cassandra, Elasticsearch. So again, send me your resume. So basically, what this presentation is going to be about, it's going to be about Puppet in 3 stages. As I kind of traveled down through to different teams at Bazaarvoice. One of those is in our legacy stack. It's actually paying the bills. And then in our 2.0 data infrastructure team, that focus is going to be on a master client-server architecture, your traditional Puppet architecture. And then Puppet in the data services team. That's going to be a focus on master lists, so a lot of Puppet applies. Also, as I work through and talk about these different ways that Puppet is architected, I'm also going to make comments about how we architect, or how the DevOps workflow changes as a function of how the Puppet architecture changes and the automation changes. The talk will be based mainly in AWS, so if you have any questions about AWS, let me know. I've been hearing some talks about some people want maybe a little bit more clarification about, like, you know, some of the more basic stuff of Puppet, like factor or whatever. So let me know if you need me to explain anything in depth about stuff like that. So Puppet in the legacy infrastructure. Like I said, it's a traditional Puppet master client architecture. You have a bunch of clients and they all check back into the master. The way we have things set up, we make great use of multiple levels of node inheritance. So whenever a host checks in, it's going to have a host name that will map to a node definition in the nodes.pp. So right here in my little code snippet there, you can use your imagination. That's kind of what that's supposed to be showing. And then under there, the node might inherit code from several other nodes. Puppet managed instances are configured according to the DNS naming convention. So we had a naming convention. We would have like DB-MySQL-whatever. That would be the actual host name that would determine what puppet code the instance would receive. So this kind of, first off, these design intentions or design implementation intentions, they kind of cause some issues. One of the things I didn't speak about, but also is that we had one monolithic Puppet module code base that many different teams manipulated. So you had people making changes that they didn't really feel like they didn't think about other teams that might be affected by the same change. So this made work to do very hard to work with, very complex. You make a change just for what you do, and then you don't really consider the consequences. Kind of go on to say it's just a large code base. It's kind of that Jenga tower of Puppet code. Another thing is too many pivot points. We had many areas of being able to configure changes in how we deliver code, how code got executed, and this, when you come down to it, you start thinking about it, you don't really use half of these pivot points, I like to call, and so therefore it's really, you're just kind of interjecting more complexity into people that are trying to follow what they're trying to do. And then also too, I saw that there was lots of code rot, lots of code that hadn't been thought of in quite a while, and had not really even been subject to refactoring. In my 4 years at BioWare, I refactored every 4 years. Not saying that's like, I'm not saying that I think that's a good way to go, but I do think that yes, there needs to be time, especially on monolithic code bases, that you need to refactor your code, throw out old stuff that you don't need anymore, make some stuff that you do depend on run better. So during my time in the infrastructure team, I was kind of brought in to kind of re-architecture the way some things worked in our Ireland cluster. And then actually, I had to get changed over from the infrastructure teams where we did big data stuff like Cassandra, Elasticsearch, those kinds of things. And so I got to actually implement myself these principles that I was working toward in the infrastructure teams. So going forward, I kind of did some rethinking on all this stuff. So I knew what I wanted to do was not have nodes defined by their host name. I didn't want to depend on a host name being correctly formatted to determine how Puppet code would get delivered to a particular host. So therefore, I wanted to rely on role. I wanted to just be able to say, as a Puppet client checked into a Puppet server, it would just basically say, I'm a web server. And then I would deliver whatever it needed. A lot of the operations in the data infrastructure team was centered around an Uber IT tool server that ran everything that you would need. So it would run Git collective, Git, where actually Git repositories are kind of laid down. And then also it would run the Puppet server, of course. I call this the mothership. On the mothership, I used very liberal use of Hira and parameterized classes to try to create generic Puppet modules that can be reused for different roles. So that's basically one of the things that I really tried to do, is because I knew that coming into these teams, these infrastructure teams, I was going to have 4 different particular teams that were going to be working with it. It was a little bit different than coming from the PRR, where it was probably much greater than that. It was at least 10 different teams working on the same code, but I kept feeling like, well, if we just parameterized all the classes, used Hira, we won't run into the same problems that we had at PRR. You'll see what really happened with that shortly. Development would be centered on using Puppet environments on the mothership to protect devs from stepping on each other. So basically the workflow, and I'll outline this more as we go forward, the workflow was that devs would log into a mothership, and if they wanted to work on a particular application, they could pull down the what we call the data team Puppet module, which is all the different Puppet code that runs on a mothership. They'd pull down and make a local branch on the mothership, but then they'd be able to create a self kind of ensconced environment that only they could work in, and then hosts that they spun up, they would only talk to that environment. And at any one time, you probably had 8 different developers working on a mothership that would be working against 8 different environments. And it was all well and good, and it worked. A little bit about the mothership. Like I said, it contains a cocktail of different application tools, and that's really all it is. When I say mothership, that was just like a cutesy name I gave to it, because at Bazaarvoice we're into cutesy names. But basically, there really wasn't any kind of special sauce to it. It was both an M-collective and active MQ server. It was a Puppet server, and it's also kind of the place where you put just ad hoc scripts that you would need during any kind of operations maneuver. Mothership was configured to be highly available in regular AWS fashion, so we actually automated it where it would be running in an auto-scaling group, and if it fell down, then the auto-scaling group would recreate it. And then we were also making it where it would be scalable, so when they came, whatever time, if I had too many clients talking to it, I could spin up another one, and then they would run in parallel with each other, and connections would load balance across them. And also, as I told you, it would advertise multiple public environments, clients and clients could switch between these environments via, and if you're aware of how the Puppet agent, Puppet space agent -- environments, what that does, you were able to select which environment you wanted to run across. Here is a drawing I kind of made just to kind of illustrate that. What we have going on the left side is, and I'll talk more at length about this, I'll talk about it right now actually. That's actually what we call a universe. And what a universe is basically a logical grouping of servers in a particular stack. And this universe applies to servers that across applications. So basically, for the data infrastructure, we call our database emo. You would spin up an emo stack, and then you might need to spin up some data services stacks that might be the web servers or whatever that display the data that's coming from emo. But by giving it the same universe name, it was assumed that they would all talk to each other and not outside of that stack. How this kind of parlays into the Puppet environments that I talked about, we have different universes for each different environment. So if I was a developer Bob, I wanted to work on some code, I could log into the mothership and then create my own universe with my own stack, my own emos, and I knew that they were never going to interfere with anybody else's. And then Joe could do the same. And that's how we did development. A little more introspection into the anatomy of the mothership. Kind of reiterates kind of the things that I was talking about here before. The mothership contains all those things that you would need for good, healthy operations in the cloud. You got your Puppet server and your Apache Passenger, so you can make sure that you can scale those Puppet connections. Multiple Puppet environments. The M Collective client is installed on the mothership, the idea being that if you want to do some kind of operation, some kind of like ad hoc SSH command or whatever, you can just log into the mothership and then type it out. And I just want to say that one of the biggest problems that I wanted to solve with having a mothership is I wanted to have a server that was sitting inside the network of wherever my, wherever my production, my QA was going on, and you could log into it, authenticated as yourself, of course, and then everything would be set up the exact way you need it set up. There's no reliance on making sure that your laptop is set up correctly to run certain tools. Everything would be set up the right way. And the way that was achieved is that the mothership server was a Puppet client of itself. So in cron, we would have Puppet running probably, I believe, every 5 minutes on the actual mothership server, and it would just connect back to itself and configure itself accordingly. And then up here, at the top right, my right, your left, there's the managed node, which has the M Collective server, which kind of like in M Collective speak. It's like your client. It's what you want to manage. And it's constantly checking back to the ActiveMQ server for messages that the M Collective client would be submitting. So moving forward. So, but one of the really great things about Puppet is being able to pass in data. Being able to write generic stuff that I can just pass in data, and passing that data in dynamically is even more interesting. So we used liberal amounts of here at data store, the Puppet standard lib tags.txt, which I think in factor 1.7, that's going to be the external factors. I'll be looking to fold that in, and then probably get rid of standard lib after this point. And then on the dynamic tip of getting stuff in not through here, because developers aren't really keen on using here, but being able to supply a value like foo equals bar at CloudFormation instantiation. This is where it starts going to AWS. I could actually do that. I could submit, I could supply CloudFormation parameters, and they would actually get injected into the Puppet standard lib tags.txt as a value mapping, and would be able to do all kinds of pivot points that way. Let me drop into that in a little bit more detail. So the bootstrapping process, using EC2 user data, populates etcfactorfacts.dtags.text with mappings. So that's the standard lib function I'm hoping a lot of people are familiar with. So basically, if I were to provide the universe value on instantiation, I would have the CloudFormation parameter universe equals whatever, and then that would get translated down into user data, and then during user data stand-up, it would pipe in universe equals dev, universe equals foo. And then these values that were in tags.txt, they would immediately become factors. And then I could do my pivoting that way. A little bit about the here at data store. I use that extensively, like I've been saying. Use that to pass in data according to context. So the different contexts would include what Amazon region, what instance role. Instance role was my role, whether it was a web server, Cassandra server, whatever. What universe. Or app version. Consider the example that I have right there. App version Hira looks for a key app version within my Hera data store, and if it doesn't find it, it's going to return nil, and then I'll have errors. I'll fail fast. So what does all this contend on? It contends on the Hera YAML file. So basically, I think this is pretty self-explanatory. You'll see a lot of these pivot points, like on the Hera data file, like tag region, universe, role. Those are actually factor values that get populated during user data stand-up, and then they're available to Hera. So as I start standing up hosts and I stand up a host in US East, that's its tag region, and then the universe is dev. Well, if I have a value in that 20 common YAML file, it's about the third line down, that I have a key that I'm looking for, say app version, it's going to take that value. The first match wins, of course. So let's drill into a little bit of the Puppet environments universe. I think you're going to see this slide one more time because it's such an awesome drawing. But it just kind of basically reiterates how we were doing the environments. You got Bob. He wants to start up his own stack. So he's going to create a universe, and he can work on his stuff. And if he wants to work if he has to stand up a data infrastructure stack for his application to work, it's on him to do that. Bob will have to do that himself. Later, and I can cover this a little bit, later in data services, we started having the pivot point where you would submit, okay, what is my data infra universe as a part, independent of my actual universe? So in that manner of thinking, Bob could stand up a universe equals Bob stack, but his data infra would be dev, so he could still call out to the infrastructure that was in dev, provided he wasn't doing anything that was intrusive to the data, because other people would be using dev as well. Here is kind of the way the mothership works, the mothership execution flow. It starts over on the left side, your right, with the Puppet client. The Puppet client contacts mothership server with a Puppet agent -- environment call. That call, that environment value, of course, is resolvable on the mothership. So again, let's talk about our buddy Bob. Bob's going to go Puppet agent -- environment Bob's universe. It's going to call back to the Puppet server. The Puppet server refers to the puppetmaster.conf and gets the module path and manifester given for Bob's universe environment. That's illustrated in that rounded square, the text there. And that's really what an environment is. It's really just a collection of manifestors and module paths. That's all. And then once you give the Puppet client that, it doesn't need anything else. From there, the Puppet client will go and seek out or the Puppet server, I should say, will seek out the path denoted in the puppetmaster.conf about where to find Bob's universe of modules and whatever, and then use that data, and these are going to be like your manifests, your module, all the .pp files, to compile the client catalog, and it ships it back up to the Puppet client. Here's kind of a list of things that I kind of put in an order of importance. The files that do the things. The etsypuppet.conf, Etsy Puppet EMB global Hera data environments.json, puppetmaster.conf, of course. And then really what's kind of like for the different environments, Etsy Puppet _EMB. So under the Etsy Puppet _EMB, you'll see Bob's universe, Joe's universe, dev. Under that, you'll have the different manifest module directories for each one of those universes. So I think that I have some not so awesome slides that I'll just kind of blaze through. But I think in this environment, I think some things to note is, and to take away that almost everything is managed by Puppet in this kind of setup. So this is a Puppet.conf that really has the most value for a client. In fact, that's the only value that it has, in that it'll set up the environment. So once every Puppet agent command, which is the command that will talk back to the server, it's run with a -- environment. That -- environment gets translated up here. This is a Ruby template, by the way, if you haven't seen that. It'll get passed through that environment tag, and then that's what it is for running. So the next run. So that's how it selects Bob's universe, John's universe, whatever. This is the same exact Puppet.conf that's running on the Puppet Master as any other agent, because the Puppet Master or mothership server is a client just like anybody else. Right here, this one is my environments.json file. So I should probably come back to this. In fact, I will. Here's the puppetmaster.conf file. This kind of gets a little bit crazy. Like I said, mothership runs itself. It's its own puppet master. So therefore, every time, say, the puppet runs, it will reevaluate its puppetmaster.conf, and if there's any changes, then it's going to restart Apache Passenger, it's going to restart everything, or reload it. So one of the events that would kind of trigger this event is and remember the workflow, if a dev logs onto the mothership, and I'll go into how this works. If a dev logs onto the mothership and they're saying, Joe wants to make his own universe because he's got to work on his application, I had a script that he would run, and it was basically create universe that would pull down a copy of our data team puppet module. That was the GitHub module, if you recall, that we kept all the code in, and it would create a local branch under etc puppet env, and then it would update, the script would update the environments.json. So here, I've got the head key is environments, cert, which is a universe name, universe/environments name. Cert's another name that we call QA at Bazaarvoice. But just replace that with Bob's universe, Joe's universe, whatever. This data would be put into there, would be put into the JSON file, and then Puppet would start running through and reevaluating its configuration files. And you see that right here, because in the hashtag environments, it's kind of some nasty code. Well, in puppetmaster.conf, that's what establishes what environments are available to clients. What we're doing here, or what I'm doing here, is I'm reevaluating the contents of the global environments.json file and seeing all the different environments that need to be available, and I rewrite this inside the puppetmaster.conf. It looks really nasty because, as a side note, because I had originally wanted to write it as just a hash of hashes, but as programmers would know, hashes are unordered lists. So what I was seeing is every time I ran, the file would totally get rewritten every time. So I had to make it an array of hashes. So this is just kind of like the basic site.pp. It's not really all that awesome, except for it does kind of point out one thing that I was going for. And I think this will reiterate kind of what I think Dave Nally was saying too. This is how I handle all my nodes. They're all node default, every single one of them. I don't mess with like trying to use regex to capture the host name, to figure it out. Everything's a base node. But then by virtue of using tags or Puppet standard lib tags.text, aka soon to be external facts, I make a factor called tag underscore role, and that's going to equal Cassandra, whatever. I call that. I evaluate the value of tag role, and that maps to an actual class that I have. And that runs it. It makes things a lot simpler trying to figure out how stuff's supposed to work. What do we got here? Let's see if we can be just base node. Nothing really all that exciting about that. We all need security. We all need monitoring. This is the mothership role. I think the most interesting thing about this is that it's using the same Puppet module as every other client uses, except for the mothership, master equals true, when most of the time master equals false. And there's the drawing again. Isn't it awesome? So yeah, and this kind of works through the workflow. So I kind of spoke to this again, that if Bob wanted to work on his stack, he's going to log into Dev Mothership, he's going to run the script, it's going to pull down the Data Team Puppet GitHub project, make a local branch in Etsy Puppet env Bob's stack, and that's going to have all the stuff he needs to create his own stack. And then going one step forward, he would make his CloudFormation calls that would say universe dev Bob stack. And then all those hosts that would come up, they would talk back to Bob stack. So I was pretty happy with a lot of this. It worked a lot. The workflow paralleled a lot of ways that I was really comfortable with working. Most of the times when I had to do development, I would do it on the server. I would do all my commits on the server because I was also testing in a real, production-like environment in AWS. So I was happy with that. But the things being what they are at Bazaarvoice, one of those things being that I was the only operations person spread across 4 different teams. It doesn't really make sense for me to be on top of every operational move. Really, it makes more sense for me to kind of stand at the high level and try to make tools, orchestrate processes, teach the devs how to do those things. So I was talking to one of our developers, and I was like, "Yeah, everything's working out real well. Do you like how the workflow is going?" Meh. Well, what don't you like? Well, I just don't ever log into the mothership. I didn't know how to deal with that, but I did deal with it, and I started to recognize that, well, if you want these guys to continue doing your job, then you need to give them a workflow that they like. So with that, I did some of this work in data infrastructure, and then I got moved into the data services team, and we got rid of the mothership. And now we're on masterless Puppet. Still keeping bits and pieces of the mothership project. Applications, services, scoped in Zookeeper by universe. That's one of the things I'm keeping. So if you're in a universe, you can only talk to the infrastructure that's in your universe. You can still say, I want to talk to that universe, and I'll get into that a little bit more for certain applications. But for the most part, that's the idea. That's the idea. If you deploy to production, you only talk to production advertised services, and that's it. A lot of emphasis can be put on making things simpler. I kind of fell into that same pothole that we did with the production stack, where we had this monolithic code base, 4 different teams working on the same code base. You don't think it's really that big of a deal, but we did generate a whole lot of code, and people were stepping on each other, and people were making other people on other teams having a bad day because of their changes. Because what would happen is most of the times they would make a change, they would test it in their scope, on their application, but they wouldn't spin up other people's application to see if that was still working okay. So we're gonna make this be very, very condensed. So in data, I did this for data infrastructure, and I'm done doing this for data services. But so each individual team, data infrastructure, the term is a term for an umbrella that encompasses 4 different teams. Data services encompasses 2. I made them each a GitHub repo, and I would call it like we had I said that our database was called emo, so we had an emodb ops GitHub repo, and that contained all of the operational code that you would need to do anything, including the public code. And in that was only the modules and manifests that have anything to do with emodb. And in doing so, people would only be making changes that would impact their team, not other teams. A lot of people like to call out that maybe one of the negatives is that I'm like doing a lot of code repeat. People are maybe kind of reinventing the wheel in some places. And I think at Bazaarvoice we keep that to a minimum by really communicating with people that aren't in our team to kind of find out, well, how are you doing this? How are you doing this? So I think that that's kind of at a minimum. So one of the biggest things, or one of the things I like to think about is how do I get data into Puppet? And it's the usual suspects for masterless. It's Puppet standard load, tags.txt, Hira, cloud formation parameters. But then I kind of went a step further. EC2 tags. Now in masterless Puppet, every time a node comes up, all of its EC2 tags are instantly factors. And Zookeeper. I've got some routines that actually call out to Zookeeper. I don't know if a lot of people know what Zookeeper is. I'll just say it's a distributed key store, very light for applications to kind of call out to it and say, oh, you know, I need this configuration piece. It's a little bit like Puppet, but it's more developer centric. And it's one of the key store. It's a mode of configuration that we use at Bazaarvoice. And then it's centered around the CloudFormation parameters deploy tag, and I'll talk about that more some more. This is that, I want to open source this, but this is a script that runs on all the nodes. Get EC2 data cache. So that's basically the script that runs every time Puppet runs, and it will grab the EC2 tags and create those and make those as factors. Here's some functions that I talked about. Zookeeper, Ostrich. Ostrich is our kind of layer that we put on top of Zookeeper. So basically, we kind of use that to our advantage to trying to figure out and communicate kind of like enterprise-wide big options. So here's the masterless execution flow. Begins in the top left again. You're right. It begins with user data running, and it will communicate back to, I know I'm running out of time. So I'll just skip across this and just kind of come straight here. Do I have 0 minutes left?
Pretty much.
Can I just leave you all with this one really great? So this is basically kind of sums up what I was talking about. User data, the developers work on their work on the Git code, pull it down to their laptops, because all development's going on the laptops. And then when they make a push, I call it the tag and push. They push that data up to S3, and then they start the instances. They give it the version, they give it a name of the deploy tag, which tells it where at S3 to grab their Puppet code. It grabs it and it runs. And it's a lot lighter and it's more better. And I think that's it. Do I have time for questions?
Well, 2 questions.
No.
Or not.
All right. What's up?
What was the way that you used to get secrets out of those individual developer Flutter repos?
What do you mean?
How are you handling credentials in production systems, for example?
Yeah, so, well, in AWS, we use instance profiles. I don't know, are you familiar with that? Yeah, so that's what we're using for that, for instance profiles. But as for like application stuff, we don't really have a whole lot of instances of needing to have passwords. As an artifact of the like EmoDB ops repo or whatever, I have a keypass database that I commit to that repo, and then I put stuff like certain passwords or the default key pair that people would need into that keypass database.
Unrelated follow-up question. How do you manage stuff like mcollective, or do you just not use any of those additional features that a master would provide?
No, I love mcollective. Mcollective kind of manages itself. But basically what it is, every time the mcollective setup of the server is in the common module, so it just gets set up automatically.
So are there still some modules that you have on every single node, even though developers maintain their own repositories?
Oh, yeah.
Those individual things. Like,
Oh, yeah.
Like how do you make that baseline shared and consistent across those repositories without having it forked differently on each one?
So it's not shared, the repository is not shared between the different individual developers. It's really shared amongst this team. So they all work on the same GitHub project, but they'll just pull and fork from that, if that answers your question.
Okay, so you do have like 4 separate like security repos that all handle the same common code setup. Okay, so you don't have like a baseline master repository that other people generally like rebase from.
No.
Okay.
No, and really I kind of feel like that's part of my job is to, whenever somebody does something in Cassandra or whatever, I need to go, like if emo team does something with Cassandra that's really awesome, and then I want to go to this other team, I go, I know you're using Cassandra, emo team did this, let's port that stuff over there. It's a manual process. I feel like that's my job.
Okay, I just feel like that is a point of scale that's hard to maintain after you reach a certain number of teams.
Oh, I agree.
The challenge that trying to figure out.
I agree, and I think right now I'm kind of a wait and see because it's fast now. So that's kind of where I'm at right now, but I would agree with you. Yeah.
Okay, thank you.
All right.